It's what will take us from roughly 2,500 tons to orbit per year to over 1 million tons to orbit per year, and I think maybe even to 10 million tons per year. These are mind-boggling numbers.
SpaceX launched Starship Flight 14 to carry viable payloads into orbit and then bring the upper stage back to the launch tower for its first catch attempt. The company is tentatively aiming for the end of August, although it still needs regulatory approval and a clean review of the previous flight, Flight 13. SpaceX has caught Super Heavy 3 times, but has never tried to catch a 52-meter ship after orbital reentry. Now, can Flight 14 really go from useful payload deployment to a tower catch on the same mission? Now, Flight 14 asks Starship to do far more than repeat another hour-long trip to the Indian Ocean. We're going to go through the likely hardware, the orbital flight path, the payload deployment, the deorbit burn, the return to Texas, the catch sequence, the booster problem, and every decision that could send the ship away from the tower. Now, Flight 14 is supposed to take Starship from suborbital testing into orbital payload delivery. Flight 13 clears several of the basic ship tests by deploying 20 functional Starlink V3 satellites, restarting a Raptor in space, surviving entry, and landing intact in the Indian Ocean. That flight supplied the data SpaceX needed, and Flight 14 now has to use those pieces on a harder path that ends back at Starbase. SpaceX has only given us a tentative end of August target. The company had not published a Flight 14 mission page, launch window, payload count, or official timeline by August 11th. Musk said the ship catch depends on the Flight 13 review, finding no new problem and regulators approving the attempt. Now, those conditions can move the launch, change the return plan, or remove the catch while leaving other mission goals in place. Now, I expect SpaceX to fly Ship 41 and Booster 21, but SpaceX has not confirmed those assignments on a mission page. Ship 41 has already passed structural tank testing with cryogenic fluid, and Booster 21 has entered its own pre-flight test flow. Both vehicles still need to finish engine work, ground testing, final inspections, transport, and stacking before launch. And I would treat every hardware assignment as likely rather than final until SpaceX publishes it. Now, the V3 stack stands about 408 feet tall and uses 33 Raptor 3 engines on Super Heavy. The ship carries 3 sea-level Raptors for landing and 3 vacuum Raptors for efficient flight in space. Flight 14 should begin with the same basic sequence we saw on Flight 13, including liftoff, maximum aerodynamic pressure, my favorite part, booster engine cutoff, and hot staging. The mission becomes different once the ship finishes ascent and commits to the orbital path. Now, past Starship flights reached space without settling into a lasting orbit. They followed suborbital paths that naturally carry the ship toward the Indian Ocean, even if the vehicle never restarted an engine. Flight 14 is expected to leave viable payloads in orbit, which means the ship must reach the speed and trajectory needed to keep those payloads circling Earth. Now, the ship then needs its own deorbit burn because gravity will not bring it home on the first pass. SpaceX says Flight 14 will carry Starlink V3 satellites, although the company has not announced the number of those satellites. These spacecraft are larger and more capable than the current Starlink generation, and Starship is a launch vehicle built to carry them in volume. Flight 13 proved that the PEZ-style dispenser could release 20 working satellites and that engineers could contact all of them over radio and laser links. Flight 14 must release its payloads at the correct orbital position and leave them with a usable path instead of a planned re-entry 20 minutes later. Now, payload deployment also changes how we should judge the mission. A clean ship flight with no useful cargo would still give SpaceX engineer data, but Flight 14 is supposed to start delivering working hardware to orbit. That puts the payload door, dispenser, satellite separation, communications, and orbital targeting on the same list as engine performance. And SpaceX will need all of these systems to work before the ship even begins the trip home. Now, the deorbit burn may look small on the webcast, but it controls everything that follows. Starship has to settle liquid methane and oxygen near the engine inlets after coasting in low gravity, restart a Raptor, and change its speed by the right amount at the right point in orbit. A burn that starts late, ends early, or produces the wrong thrust could move the entry point hundreds of miles. SpaceX demonstrated a V3 Raptor restart on Flight 13, and 14 must use that ability to target an actual return corridor. The return to Starbase gives the ship a different job than its previous ocean landings. Starship must enter at the correct angle, manage heating across the tile-covered side, and use banking turns to control both distance and direction. A shallow entry can send the vehicle long, while a steep entry increases heating and aerodynamic load. The flight computer has to manage that energy while steering toward South Texas instead of an open section of the Indian Ocean. More than 18,000 ceramic tiles protect Starship's stainless steel body during entry. Musk said the Flight 13 result left him confident that SpaceX had solved the heat shield problem, but one clean return does not establish repeatability. Flight 14 will expose a new ship to entry heating and then ask it to continue flying over land toward valuable ground hardware. SpaceX needs the shield, the tile attachments, and the steel underneath to stay healthy enough for precise control all the way back to the tower. And the 4 flaps take over more of the work as the ship slows down. They control attitude, drag, and range while Starship falls mostly sideways to the atmosphere. And near Starbase, the ship must reach a tight approach corridor with enough propellant and control authority left for the landing flip. Now, a flap problem that still allows an ocean landing may be unacceptable when the target sits beside the launch tower. Now, the final approach starts with a maneuver that looks completely wrong until the engines light. The Starship falls belly first, swings its tail underneath it, and starts all 3 sea-level Raptors for the landing burn. The vehicle can then produce the number of firing engines as it slows and lines up with the catch arms. Flight 13 stepped from 3 engines to 2 and then 1 over the ocean, while Flight 14 has to finish the sequence at a specific height and position beside the tower without destroying it. Now, Starship does not carry normal landing legs. The launch tower's 2 mechanical arms must close beneath reinforced catch points on the ship and take the vehicle's weight while the engines shut down. That design saves the massive landing legs and keeps more complex hardware on the ground, but it leaves almost no room for a poor approach. Navigation, thrust, wind, flap position, catch arm movement, and tower health all have to agree during the final seconds. Now, SpaceX should have several chances to abandon the catch before the ship reaches the tower. Previous Super Heavy returns used automated checks of the vehicle and tower, and Flight 6 diverted its booster to the Gulf when tower hardware failed a healthy catch. Now, FAA planning for Starship returns includes Pacific contingency areas if the vehicle cannot continue toward Starbase. The safest version of Flight 14 allows the ship to prove orbital flight and entry even if the tower catch gets scrubbed and called off. Now, the booster creates a separate question for Flight 14. SpaceX has not publicly confirmed whether Super Heavy will return to the tower, splash down, or fly another experimental landing profile. Flight 13 completed the high thrust boost back phase with all 33 Raptor 3 engines, but only 8 of the 13 engines commanded for the landing burn ignited, and the booster hit the Gulf hard. Booster 21, if it receives the assignment, must show that SpaceX has corrected or contained that engine start problem. Now, the regulatory work reaches beyond a normal launch license because Flight 14 may bring Starship back over a return corridor to Starbase. The FAA has completed an environmental review covering additional trajectories, temporary airspace closures, Boca Chica landings, and backup landing regions. SpaceX still needs the license authorization that applies to the final mission plan. Musk directly tied the catch attempt to that approval, so a launch target does not guarantee a return to the tower. Now, I'll judge Flight 14 in layers instead of treating the catch as the only result. The first layer is a clean V3 ascent, followed by orbital insertion and useful payload deployment. The second is the Raptor deorbit burn, controlled entry, heat shield performance, a flap guidance back toward Texas, and the final layer is permission to approach the tower, a very stable landing burn, and also, finally, a catch between the loving arms of the tower. Now, watch the decision points when the mission flies. This webcast that SpaceX does should tell us whether all ship engines complete ascent, whether the payloads enter a stable orbit, whether the in-space engine restarts, and whether Starship stays on its return path. The most important call may come late in the flight when SpaceX decides if the vehicle and tower are healthy enough to continue. A divert would protect Starbase while preserving much of the orbital test data. Flight 14 could give SpaceX its first orbital payload delivery and its first recovered Starship upper stage in one mission. The late August target remains tentative. The hardware assignments remain unconfirmed, and the tower attempt still depends on data and regulatory approval. The mission will show whether Starship can move from ocean testing to useful orbital work and a controlled return home.